seats. Pushing. Yes. Pushing it. Fully in class, hold it out. You're happy. Sit. On your seats. Shove your hands as I spray you. Keep on over from there. Go to the office. Good enough. Why? Okay, go to the office.
Good luck.
Hands. Shove your hands. I get you. Get you. Am I adding time to the end of class? I do not hear Chinese, no matter what, in this room. Alright. So, at this point, students, I believe we have finished our last lesson. Am I correct? So we have, I think, at this point we are on review, but I could be wrong. Let me double check. Okay. No, I do have one thing I want to cover, and then I am done. So, students, what I would like to do is show you a little bit of quick circle vocabulary that I could put on your midterm. I really, right now, these are words, this chapter 10 here, is a chapter that I don't really actually thoroughly cover because it is covered well in your Chinese class, Chinese math. But I do want you to know some of the English vocabulary. Alright, so I'm going to show you some vocabulary words right now. This is in chapter 10, 10.1 and 10.2. I don't know if you have that in your notebook. But if so, write notes. If you don't have that chapter in your notebooks, then write that in the back. But what I'm going to do here is give you guys a little bit of vocabulary, and that's it. I'm not going to actually go over the math because, again, as I said, it's covered in your Chinese class, and I don't have the time to go over that. So, here's quick vocabulary. If you don't know, this thing's called a circle. But we have a formal math definition, which makes it sound really fancy. Okay? A circle is the set of all points in a plane that are equidistant from a given point, called the center. Yes?
Which section?
This is chapter 10, section 1. But I'm not sure if we have that. Let me double check. I could? Yeah, so I'm jumping over to chapter 10 here. Okay? Page 58 in your notebook and in your homework book. (102). So 102 in your homework book, 58 in your notebook. Alright? I recommend just writing down these notes, writing down these vocabulary words here. And then I can continue to use these vocabulary words moving forward. Alright? So, again, here's a circle. The center, we name circles based on their center. So, a circle with center P is called circle P. So we name this circle circle P. Alright? So that's how, and we give it this little notation here. A circle with a dot in the middle and then the center letter. Alright? And we call this circle P. Why? So this is how we name circles. Just like before we had triangle, A, B, C, and parallelogram, you know, D, E, F, G. We also have circle P, or circle some other, whatever the letter is, in the center. Alright, so that's how we name our circles, based on their center. Make sense? And then here's all the vocabulary that I'm going over. I'll go through these words one at a time. First, let me give you a picture. Then I'll go over the actual full definitions. So here's a circle. If I draw lines in the circle, you already know one. The one going all the way across and through the middle, called the diameter. You probably also know the radius from the center to any side, any edge, right? Is called the radius. But you probably do not know the word chord. I think that's a new one. Any line from one part of the circle to another, right, part of the outside, that is not a diameter, is called a chord. Make sense? C-H-O-R-D, but you do not pronounce it chord, you pronounce it chord. And then these words down here are probably completely new. And these things down here are probably completely new. If I have a line that goes through, it's like a chord, but it just keeps going through forever, right? It's a line, not a line segment. A chord is a line segment. A secant is a line that goes through forever. Then a line that goes forever but touches at exactly one spot is called a tangent line. And the point where it touches is called the point of tangents. So that's it. This is what I want to go over today. I'm not moving off this page here. I'll be on here this whole time. It's chord, radius, diameter, center, secant, point of tangent, and tangent. Yes? How do we figure out the length of the chord? Well, this actually is interesting. So to find the length of the chord, and this is something you'll be going over in your math class, in your Chinese math more. We actually need to know this angle here, right? If I know this angle, let's say this angle is 60 degrees. Okay? Then, well, I can figure out how far this is, because it's part of the circle, right? And that, well, actually, at this point, I've got a triangle, right? This is a radius, this is a radius, r 60, right? So now let's look at that triangle for just a second. Actually, it's kind of interesting. Finding the chord length is harder than finding the arc length. So I've got this circle, this triangle here, 60, r, and here's your chord you're trying to find, right? There is a formula that you guys will learn in chapter 9. This is chapter 10, so I can build on chapter 9 stuff here. But I haven't covered that yet. This is called the law of cosines, which says that c squared equals a squared plus b squared minus 2ab cosine c. This is the Pythagorean theorem. It takes the Pythagorean theorem and adds on this little bit, which deals with triangles that aren't right triangles. This isn't a right triangle, right? That's not going to be a 90, none of those are 90 degrees. So we have to use the law of cosines. In this case, our c would be what we want, our a would be r squared, b would be r squared, a be r squared, cosine of 60. And you can actually, if you tell me what r is, you choose the radius, say 1 or 2 or whatever, you can actually type this whole thing in your calculator, and it'll do it. But we haven't covered that yet. As I said, right now, I just want you to know what these things are. We're not calculating how long they are. We're not doing area or anything with them. Just making sure you know the vocabulary. That, yes. The cosine? If it's without using a lot of the cosines, it'd have to be like very limited. I don't believe there's a nice way, is there? Do you know? Do you know one? I don't think there is. I think in this case I'd have to use a lot of cosines. I could be mistaken. There might be a shortcut that I'm not seeing, but I believe I'd have to use a lot of cosines. And so I'd have to use a more complicated math form here. But shortcut for diameter, of course, right? If your chord happens to be the diameter, that's really easy. But it's just twice the radius. But knowing, you need so much information about the chord. You need to know exactly where these 2 points are. If I knew these 2 points, like I knew the equation of the secant line and I knew the equation of the circle, I could figure out where they intersect, and then I could get both those points and do distance formula. So it really depends what you know. But assuming what you know is the radius and the angle there, then I would use log cosine. It's not that bad once you know it. But we haven't covered that yet. Again, right now, these, I think you should already know diameter, radius, and center. So these 1, 2, 3, 4 vocabulary words are what I would like you to know for today. And also to be able to understand the formal definition of a circle. That's all I have. Any questions? Tangent. So, again, a secant is a line that cuts through a circle. Twice. 1, 2 times. Right? It intersects a circle twice. Most lines are secants. But if I draw a very special one that just touches exactly once, it just barely touches it. It goes, touches it, right? Right? So if I zoom in at that point, right, it's going to look like this. Here's the circle. Here's your, it's really hard to draw, but it draws exactly once. And it's like it just barely kisses it. It touches exactly at one spot, not 2, 1. That's called a tangent line. And they're very important when we start talking about calculus. But for now, I just want us to see the word tangent. Yes?
With the PowerPoint on Google Classroom.
I can try. Let's see what I can do. Yeah, but no promises, but I'll try. I don't know, I'm not very good at these computer things. Computer things are confusing. I don't know. Back when I was a kid, we just had rocks. Yeah. Fire was the new big thing. So, yeah. I'll try to understand these moving pictures, but I think I can do it. Alright, so, yeah, that's about it. Not to go off on, and also just not to go off on a tangent, but the word tangent can also be used. For example, you students love to do this. Alright, so I say one little thing, maybe about, me being old, and then you guys try to start like a whole conversation about me being old. You ever do that with your parents? You ever do that with your friends? Or does any of you guys do that, where you're talking about something that somebody quickly mentions one little thing that's a little related, and then you start going off and talking about that weird thing, right? That's called going off on a tangent. What that means is the topic you were talking on barely touched, and then it went somewhere else. So the word tangent actually is used outside of math too. It just means something that touches barely, just barely touches. Make sense? Yeah? Alright, so there's the vocabulary for the day. I will now start let me actually go through a few problems. AC. What type of line is that? Is that a line, ray, segment, or sorry, is it a chord, a radius, a diameter, a secant, or tangent? AC? AC? Line, segment, AC? It's a radius. Right, James? How about AB? Line, segment, AB? Diameter. How about ray, DE? Ray, DE? Tangent. How about AE? Ray, AE? It's a secant. Very good. It's a secant. Make sense? It intersects 2 times. How about line segment AG? A chord. Now notice the difference here Be really careful. Be really careful here. AG with a line. This is a chord. Oh, chord has this A. But if I change it just a little bit, this is a secant. Do we see the difference here? AG is a chord. AG is a secant. Line segment AG, chord. The line AG, AG is a secant. So if I stop it here, it's a chord. If I let it go on forever, in one direction or both, it is a secant. That's the only difference. Make sense? Alright, there we go. Got those words under our belt. Now I can start our review for our midterm. Alright, so we did not have homework. We did not have homework? Oh, wow. You understand that I have this all recorded, right? So everything you do is on tape. Yeah. And that I can give you a demerit once I watch the tape afterwards, right? Just making sure you understand that I see you from both sides right now. I'm seeing the front of you and the back of you. Good. This allows me to have eyes everywhere. An eye in the back that never looks. I'm thinking about putting cameras all around, in every desk, looking at each one of you. And I can just monitor each and every one of you. Alright, so before that happens, questions? Students, this is your chance. Questions for the midterm. This midterm will be covering chapters 7 and 12, but 12 I stop at 12.4. So 12.5 and 12.6 will not be covered. Alright? We are not doing combinatorics or the binomial distribution in this class. But everything in chapter 7 is fair game. And everything 12.1 to 12.4 is fair game, as well as anything from last semester. But I will be focusing on chapter 7 and chapter 12. Questions from 7 and 12? Like independent and dependent? James. In the front. And come on. Okay. So, the difference between experimental and theoretical probability. Alright, so experimental, okay, well, in this class I focus on theoretical probability. What does theoretical mean? Like theory. What does theory mean, Wayne?
A law.
A law? Yeah. In theory, all my students would have are signed up on the Google Classroom and checking it every night. That's in theory, right? So my theory is, in theory, 100% of my students are doing that every night. In experimental, maybe it's like 50%. Okay? Speaking of which, let's take a look at this classroom. So, theory is what it should be in the books, right? Experimental is the real world, is real life. Okay? Does that make sense? Okay? So let me give an example. I like to think about it as rolling dice. In theory, if I roll one die 600 times, so I roll a die. No, actually, we shouldn't do this. Yeah. So, what is the theoretical probability? Theoretical probability. What is the probability of getting a 6 if I roll a die? 1 over 6, right? 1 over 6. This is number of I want and number total, right? Number of favorable outcomes. Okay? Number of favorable outcomes over number of total outcomes, right? That's how we do theoretical probabilities. In experimental probability, what's an experiment?
The test effect.
Yeah, experimental probability. We actually have to do a test. We have to test it. So, when I do my experimental probability, let's say I actually go out and I take one die and I roll it 600 times and write down what it lands on each and every time. And I find that out of those 600 times, 90 of them are 6s. So I got a probability of 90 over 600, which is 9 over 60, which is 3 over 20, right? This is number of successes over number of trials. How many times I ran the experiment, so how many times I got a 6, divided by how many times I ran the experiment, how many times I rolled the die. Does that difference make sense? Experimental is going out and testing. Theory is actually just looking and counting the die. Now, will these answers always be the same? No. Could they be the same? Yes. But the larger this number gets, the more times I roll the die, the closer it should get to my theory, right? If I roll this 6,000 times, it should be closer to 1,000. Starting getting closer and closer and closer. This fraction should get closer and closer and closer the more times I run it. If it does not, if it starts to go to some different number, if it starts being like 1/5 or 1/2, something really strange, somebody's cheating. It's not a fair die, and our theory is wrong. But if it does, that helps justify our theory. Okay, does this make sense? That's the difference between theoretical versus experimental. All right, now the following students: Amy, Alex. Where's Alex? Again?
He fell down.
Oh, okay.
That's Monday.
They'll be here tomorrow. James Chuang, Leon, Lorena, James Wu. All of you stand up. Yeah. U5 will be writing some lines. We'll be staying late after class. Ooh. All right. We get to do a little bit of writing because you have not completed the Google Classroom assignment yet. All right. I have not received your introduction survey. Remember, it's not enough just to sign up for the class. You need to fill out the survey. Questions? Now, do I have 19 students in this class? No. Who are the 4 students who are not in my class? Who are the... Yep, alright. If you're not going to call yourself out, I'll call you out. Everybody stand up. When you hear your name called, please sit down. Amy, Anne, Matthew, Alex, Alice, Hank, Vivian, James, James Twong, not James Wu, Justin, Leon, Lorena, Tristan, Nina, Brian, James Wu, Daniel, Carlin, Charmaine, Joelle. 4 of you? You 4 get demerits.
For what?
And will be staying late to fill out the paperwork to remind you to do this. You are not in my classroom. Why have you not signed up onto my class? Yeah, that's what I thought.
Maybe I haven't changed
Well, no, I have every name here is a name I can read. So thank you for trying to lie to me. I don't like that. Alright. Yes. Yeah. You may sit. Students, do you know how to get onto the Google Classroom?
No. Yet.
Don't worry, your writing will include the code for my class.
Yeah.
You'll be able to write the code for my class enough times to remember. Okay? Students, also, I don't know if I need to check, but I'm guessing a good amount of you haven't done your latest Khan Academy video. Correct?
Yeah.
Oh. Double check Khan Academy. Everybody listening, double check your Khan Academy video because I will be doing a very similar thing for that. Students will be punished if they are not completing the assignments I assign online. Alright? So please go to your Khan Academy. I have sent you to your school email. Check your school email. I sent you a link to a second Khan Academy class that you can log into. I will be moving to that class. Alright? That way it's linked and connected to the Google Classroom. Alright? But you can still use the old class for now. So whichever Khan Academy class you are, check them both. I know it's kind of weird having 2 classes for now. But go to Khan Academy, check out what's it called? The assignments there. If you do not see it when you log in using your school email, check the email that you used originally when I gave you the little piece of paper. Alright? So try with both emails. I'm trying to move everybody over to just their school email so everything's on the school email. But for now, I'm using both. If you have questions, let me know. The Khan Academy video is due tomorrow at midnight. Good? It takes like, I think 5 minutes to watch. It's literally a video you just have to watch. It's nice and easy. Okay. So, while I fill this out, any other questions? Austin, what's your last name? Questions on your homework? Oh, I need your. Alice, is there a problem? Sorry, Claire, is there a problem? Sorry, Alice. Keep on doing that. You two sit next to each other. Claire, is there a problem? No? So, any other questions on the homework? Or you guys just want to wait for me to fill this out? Period 3, right?
What? Oh.
3 demerits. 2 is not. Alright. Austin, Claire, Wayne, and Justin.
Hey. Nothing. the point.
9. Students, please stay quiet for a moment while I fill these out. Oh, Carlos has a question. Carlos, how may I help you?
What's the differences between probabilities? Experiment and conditional probability?
Experimental versus conditional probability?
Or you can explain.
Well, experimental and theoretical probability I already talked about. All the other probabilities are theoretical. That's all I talked about for the rest of them. Experimental literally asks you to go out and flip the coins in real life. And actually go and do it in real life. Right? To actually run the experiment by hand. Wayne, facing forward. But, all the other ones are a type of theoretical. Now, conditional probability deals with an assumption. Alright? So I'll do a quick example with these students. There are 18 students here today. Henry's gone, right? No, I said Alex. Sorry, Henry. Alex is gone today. So we have 18 students here today. Right? If I choose a student at random, what is the probability, Carlos, that you get picked? What? Very good, 1 out of 18. Now, if, Carlins, I say I'm going to pick somebody who's wearing their sweater, what is the probability that you get kicked out? And I'll count Brian's jacket as a sweater. Same thing with Wayne.
What's that name? James?
Yes, I'll count that. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people. I'm sorry, there's not 18 people here, guys. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. There are 20 people here. So, if I say the probability of choosing Carlins is the probability of Carlins is 1 in 20. But condition, if I add a condition that is the probability of choosing Carlins given somebody, no, it's not actually a given. But this would be, given I choose a person with a sweater. This is not a formal way to do this, but just for you guys to understand. My condition is I choose somebody with a sweater. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 people have sweaters. So the condition is 1 out of 17. Only 3 of you aren't wearing sweaters? Wow. Okay. Make sense? That's the condition. The condition changes the bottom. Typically, that's what happens. It changes the group we're talking about. It changes our total to a subset. Alright, Carlins, what if I change it to, I am going to choose you. What is the probability I choose you? What is the probability I choose you if I choose somebody who has glasses? Who's wearing the glasses right now? And James is wearing his glasses. 1, 2, 3, 4, 5, 6. So 1 out of 6, right? So this is probability of Carlin's given glasses, or given a person with glasses, 6. That's a condition. A condition is, I'm not talking about everybody. I cut it. I'm like, I know something about the person. We use this a lot in the world here, because I want to know the probability that Austin will do his homework, right?
0.
Right? But you're making some assumptions, right? When you say 0, girls, pay attention to me. When you say 0, you are making some assumptions, right? You are adding conditions. You are thinking, Austin's not a random student. Austin's different, right? If I say something like this, what is the probability that a randomly chosen student does their homework? That would probably be 90%. But here's a question. What about are students who live on campus more likely or less likely to do their homework? That's an interesting question. So maybe I go and I just look at, I say, I want to know the probability of somebody who lives in the dorms doing their homework. And so then I shrink it. I add a condition. Now I just look at people who live in the dorms. And I say this. And then, let's say that part's 100%. Every student who does it is their thing. Now, the school can go and say, hey, parents, look at this. Students who do who live in the dorms are more likely to do their homework than students who go home every day. So then, parents, you should have your kids stay in the dorms. Companies use this type of thing, where they'll compare something with or without, with the condition, without the condition. And they'll say, oh, one's better, our product is better than our competitor, right? The condition of using your hair, working using our product versus using somebody else's product. Those are conditions. Make sense? That's conditional probability. Is you are, I keep on thinking I'm hearing Chinese. But there's no way, because you don't want the class to be late because of you. Alright, does that make sense? That's conditional probability. There's like an assumption. We assume something. Alright, any other questions about probability? Or don't forget, this midterm also will be covering, let's see, it will be covering chapter 7, which is quadrilaterals and other other polygons. So that focuses on this. Let's see if I can pull this up. This thing. Do we know all our shapes? Are all our quadrilaterals? Right, we remember all these? You remember that the diagonals of a kite are perpendicular? And same with a rhombus, that their diagonals are perpendicular, but the diagonals of a rectangle are congruent? For all parallelograms, the diagonals bisect each other. You also know that a parallelogram has opposite sides congruent and parallel. You also know that a rectangle has all angles congruent, is equal angular, all the angles are 90 degrees. A rhombus has all sides congruent. A kite has two pairs of congruent sides, but they're not all congruent, and they're not opposite each other. A trapezoid has one pair of parallel, the other two are not parallel. If those other two that aren't parallel are the same length, we call it an isosceles trapezoid. All of this is just review for you, right? You know everything I just said. That makes sense to you. You're like, oh, boom, 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 Mr. Mega, I already know all of this. Right? Yeah. Okay, so, good. In that case, I can just not worry, you'll all get 100% on this quiz, this midterm. Good. Good. As you can tell, based on all the vocabulary up here, not much math, lots of vocabulary. Probability has a lot of vocabulary on our last quiz. And I just went over more for chapter 10. I'm going to be focusing on vocabulary on this. So check to make sure you know each word, you understand each word. Alright? If you study nothing else, study the vocabulary. Alright? That is what I focus on the most in this class. Now, don't get me wrong, study the math too. Right? You should be able to do the math, of course. But if you don't understand the words, you won't understand the question, and it doesn't matter if you know the math, you need to know the words. Alright? You need to know both. But focus on the vocabulary right now. I think that's normally where we struggle the most. But I think we can do a good job. And also check in on Khan Academy. Because right now I'm not giving you guys homework, I expect you to be studying. Right? So I'm going to be signing up online homework. Alright, I'm going to be signing videos for you to watch, review videos to watch, and maybe little quizzes here and there online. I'm going to try a lot of different little things out. And the nice thing I like, they give me control a little bit more now that we're signed up on Google Classroom. I found that sometimes when I message students on Google Classroom, I don't get responses. So if I message you directly on Google Classroom, I believe it goes into your email. So check your school email occasionally. I believe you guys have phones. Most of you have smartphones. Those smartphones can use the internet, believe it or not. And you can even connect your school email so that when I email you, it comes to your phone. You go, ding, Mr. Mega's talking to you. You can still ignore it, but that way at least you know I did it, right? And you can respond. But if you don't respond, it will start to affect your grade. Right now, up until the midterm here, I'm being nice because I know it's a transition for a lot of us. Okay? I know you guys aren't used to using the internet. You don't know how computers work. Get it?
What is
Yeah.
internet?
Well, I would turn those back on.
I'm not like 400.
Good. So, well then, okay. If you're getting too many notifications, then check in. But every day, when you go home, it should be a good habit to check your Google Classrooms, right? And check and be like, oh, do I have anything for Mega's class? Do I have anything for Mr. Who's another one of your guys' teachers? Mr. Who? Mr. Who? Mr. Z? Lots of other teachers. Check your other teachers' classrooms. Make sure you have that on the line. I'm going to try to assign lots of little videos. Be aware though, I can tell even if you watch other videos on Khan Academy. And I'm considering giving somehow, I don't know how I want to do it. I'm trying to decide how I want to grade. But to somehow give students some credit or something for watching above and beyond what I ask on Khan Academy, because I can't see your screen time, how much time you're actually watching videos. I can tell if you hit play on a video and then go away. By the way.
Oh.
Yeah. It tells me. It will say student left. Like student stopped here at exactly this moment in the video. The kid left. And I can even look in on your camera and watch you, get a recording of you watching this video. So please be in school uniforms every time. If you're not in your school uniform, they'll give you a demerit. What's that?
So
I love how you students take me seriously. What?
Okay, you really see their face.
No, I cannot see your face. Come on. But I can tell how much you are actually watching it. It does give me actually a lot of insight into it, which is really cool. A lot of them have like it over and over, and they'll use our unrecommended. Yeah, and then you'll fail the test. That's fine. This is just like your homework, guys. I don't do it to torture you. I do it to help you, right? Right now we give you homework as a way to structure your studying, right? So that you can use it to study, right? To help you learn how to study. When you go to college, maybe the first year they'll do that a little bit, but when you're later in college, you don't get homework, but you spend more time studying, and you basically give yourself your own homework, because that's how the real world works, right? You have to actually, when you want to learn, you have to do the work yourself. But right now, we're holding your hand, showing you how to learn, how to teach yourself. But the goal eventually is for us to be able to let go and you not to just stop learning, for you to keep going. Okay? So, study hard. You can do this. We got plenty of time, right? I got the next 3 days here assigned just to preparing for us for our midterm. I think we can do it. Actually, I've got more vocabulary to give you tomorrow. But then after that, I'm done teaching. Then I have 2 days of review. No questions?
Yeah.
Alright. Let me ask you guys some questions then. Where's a good one? Alright, here's a polygon. Don't ignore the questions, I just want a polygon. Polygon. Here is this polygon. Lorena, can you name 2 consecutive vertices? Vocabulary. 2 consecutive vertices. Lorena, if you guess, you'll probably get it right. B and C? Oh. Try again. What? A and B.
Wow.
Alright. Consecutive. What does consecutive mean? Next to each other. In a row. Okay? So A and B are consecutive. B and C are consecutive. E and A are consecutive. C and E are sadly not consecutive. They're not next to each other. Okay? The D gets in the way. Make sense? How about Shemaine? Shemaine's absent? Shemaine and Alex. Why are those 2 students always absent? It's like the same 2 every time. I feel like there's something going on.
Tristan too.
Hey. Hey, Tristan?
Yeah. Oh.
Tristan.
Anybody else?
Being a girl.
Alright. How about Nina? Here is our pentagon, right? In this pentagon, if I drew a line, oh, that's a merit. Okay. If I drew a line between between 2 points, I would get a diagonal. Give me an example of a diagonal I can draw.